Hello everyone, it's Mr. Kennedy here. In this video, I'm going to take you through three examples of questions involving equations of motion. So, question one. A cheetah can accelerate from rest at a rate of 8.93 meters per second to a maximum velocity of 26.8 meters per second. And we've to calculate the time taken for the cheetah to reach its maximum speed. So, when tackling equations of motion questions, the first thing that I would like you to do is to choose the positive direction. For this question, it's not particularly important because the cheetah is only moving in one direction, but this will be important later when sometimes there may be a change in direction. For example, if something is thrown up and then it comes back down, then the positive and negative direction is important. You're free to choose the positive direction in every question as long as you stick to it. So in this question, I'm just going to indicate that to the right is the positive direction, and I'm going to stick to that throughout. Then what you do next is you write down SUVAT, so S, U, V, A, and T. The reason we do that is these are the symbols for all of the quantities that we might have to deal with in an equations of motion question. So, as we know, S stands for displacement, U is initial velocity, V is final velocity, A is acceleration, and T is time taken. Once we've written SUVAT, we then need to get the data from the question. So if we start off with S, the displacement, we don't actually know anything about the displacement and we're not being asked to find displacement. So I'm just going to put a line next to displacement. The initial velocity we do know from the question. It says from rest, so the initial velocity is 0. The final velocity we also know it's 26.8 meters per second as indicated here. We also know the acceleration of the cheetah, it's 8.93 meters per second. And the time the cheetah takes to reach this maximum velocity is what we're trying to find. So I'm going to make that equal to question mark. Now, this is where the SUVAT part is really important because it allows us to choose the most appropriate equation of motion to use. So we don't know anything about S, and we're trying to find T. So really, this equation isn't going to be much use. This one, you could find S from this equation, but the best one to use for this example would be V equals U plus AT because it doesn't have S in it at all, and it will allow us to find T. So that's the equation we're going to use. So write down the equation of motion, V equals U plus AT. Then what you do is substitute the numbers into that equation. It's usually best to do this first prior to rearranging in an exam because you get 1 mark for the equation and then you get a second mark for the substitution. So it's always best to substitute first prior to rearranging. However, if you're confident rearranging equations, then by all means rearrange first and then substitute the values in. So once you've substituted your values, we then just simplify the equation. So 26.8 equals 8.93t, and then if we divide both sides by 8.93, we get t equal to 3.00 seconds. So time is a scalar quantity, so no direction required. And also notice we've given 3 significant figures because we're given 3 significant figures in the question. Okay, part B. So we're looking at the same cheetah here, but this time we're looking to find the displacement of the cheetah at the moment it reaches the maximum speed. So again, I'm going to choose to the right to be positive, although it's not really important in this question, it's good to get into the habit of choosing the positive direction. I'm then going to write out SUVAT again. So S is what we're trying to find this time. We know U is 0 meters per second. We know V is 26.8 meters per second. We know the acceleration is 8.93 meters per second. And we now also know the time taken, which is 3.00 seconds. So in this situation where we're trying to find S, we actually have a couple of possibilities. we can use this equation here, s equals ut plus a half at squared, which would probably be my preference in this situation because it means we don't have to rearrange. We've already got s as the term that we're trying to find. However, we could also use this equation here, and I'll show you both examples. So if we start off by choosing s equals ut plus a half at squared, our second equation of motion, and then we substitute in the data from here, which is where suvat really comes into its own. So s equals 0 multiplied by 3 plus a half times 8.93 times 3 squared. Note it's only the t that's squared, not the whole thing here, it's just the t that's squared. If we then simplify that, we get s equals, this term here is equal to 0, so we just get a half, or you can write that as 0.5, multiplied by 8.93, multiplied by 3 squared. And then if we, again, just do that on our calculators, we get s equals 40.2 meters, and the direction is to the right, although this is also indicated by the fact the answer is positive, and we know that any positive number is to the right. Okay, this equation can also be solved using the other equation. So again, right is going to be positive. We know our suvat information. And again, we can choose the most appropriate equation of motion to use. So we used s equals ut plus a half at squared previously, but I also want to show you how we can solve this using v squared equals u squared plus 2as. So write down the equation v squared equals u squared plus 2as, then substitute in the data. So we get 26.8 squared equals 0 squared plus 2 times 8.93 times s. So simplifying the right hand side, the 0 disappears and we're left with 2 times 8.93 times s. So if we square this term here, we get 718.24, and that is equal to 17.86 s. And then if we divide both sides by 17.86, we get s equal to 40.2 meters. Again, positive indicates to the right. One thing to note is we don't round the number until the final answer. That's really important in higher physics, otherwise you'll lose accuracy with your answer. So only round at the final stage. Okay, for the final example in this video, I wanted to show you a situation where the direction is important to the question. So in this question, a ball is thrown vertically upwards to a maximum height, the word maximum there is important, of 12 meters above its starting point. And what we're looking to do is calculate the velocity at which the ball was initially thrown. So this time I'm going to choose up the way to be positive. I could have chosen down the way, and that's absolutely fine as long as you stick with your positive direction throughout the question. The reason I went for positive being up the way is that's the way the ball was thrown initially. So I've just gone with up the way being positive. But as I say, you could just as correctly have chosen down the way to be positive as long as you stick with your initial choice. So up the way is positive. The next thing we do is we write down suvat, and again take the information from the question. So we know the displacement when it reaches its maximum height is 12 meters. We don't know the initial velocity, that's what we're trying to find. So I'm going to make that question mark, that's what we're trying to find. Although it's not maybe obvious from the question, we do also know the final velocity when it reaches its maximum height. Because it says it's reaching maximum height, the final velocity will be 0. If you imagine an object being thrown up, it decelerates, it decelerates, it decelerates, it reaches 0, and then it accelerates as it's coming back down. So the final velocity is 0 meters per second at the maximum height. We also know the acceleration. The acceleration is the acceleration due to gravity, which on Earth is 9.8 meters per second per second. This value is given on the data sheet in any questions that you get. So, because we've chosen up the way to be positive, the acceleration due to gravity, always acts down the way towards the centre of the Earth. So that would have to be a negative value given my choice of positive direction. So the acceleration we're going to write as minus 9.8 meters per second per second. This indicates that it's in the downwards or negative direction. We don't know anything about the time taken, so I'm just going to leave that as a blank. Okay, so then to choose our equation of motion, we don't know anything about t, and we're trying to find u. So because we don't know t, that really rules out the first two equations because we don't know anything about t. So that leaves us with this third equation, v squared equals u squared plus 2as. If we then substitute the data into that equation, we get 0 squared equals u squared plus 2 times minus 9.8, minus is important here, times 12. So 0 squared equals u squared minus 235.2. And then if we add 235.2 to both sides, we get u squared equal to 235.2. So u is then the square root of 235.2, which is 15 meters per second, and that's a positive value. So it means it's in the upwards direction, which is what we would have expected from the question because it does say the ball is thrown upwards. So if we've got a negative answer there when our positive direction is upwards, then it should indicate that something has gone wrong. Also note that I've given two significant figures with this question because in the question we're given two significant figures. So that gives you some examples of how to tackle questions involving equations of motion. I hope you found that useful. Thank you.